Assalamualaikum and good morning. My name is Normala Binti Sulliaman from Polytechnic Kuching, Sarawak. Today I would like to present a paper. My paper title is Performance-Based Approach to Evacuation Analysis, a case study of two shopping centres. Okay, this is study background. My study is focused exploring the capability and output of computer modeling into shopping center in Malaysia, and I will use software SIMULEX to analyze the total evacuation time, TT, and human behavior during people evacuate the building during emergency. Okay. Computer modeling. I will use computer modeling based on performance-based approach due to design and emergency safety for occupant. Okay, so this is my research objective. The first one is to explore the modeling, analysis, and output capability of the emergency evacuation visualization tool SIMULEX within the framework of two actual large shopping complex design. Second one, to test these design layouts against the output parameter in SIMULEX in terms of evacuation parameters, and hence analyze the result in terms of safety parameters and the capabilities of producing visual, analytical, and numerical output. Third one is to find the relationship between TT and number of exit and the width. Okay, this is the problem statement. The first one is due to large area, the concern of fire safety, particularly the exit route path, is being questioned. Usually visited by people who are shopping mall, usually visited by people who are familiar with the layout, and also first time visitor who are not familiar. Therefore, the exit route path should be located at suitable area, easy to find and not obstructed. Okay, the physical characteristics such as door width, number and width of staircase also question whether they are sufficient for occupants during evacuation in emergency. Okay, the scope and limitation of my study is the first one only limited to two selected shopping center building. Okay, the shopping center cannot be modeled as per operation but as per design because the complexity of the tenant and retailer, and this is too difficult to model. Okay, I will use SIMULEX in order to simulate the human movement and human behavior, but this software does not consider the fire elements such as fire spray, smoke spray, fuel load, something like that lah. And then I only refer Malaysia prescriptive UBBL 1984 only. Focus on this area of bylaw 1984 in evacuation area only. Okay. In SIMULEX, I will use shopper characteristic as input for calculating of evacuation time. Okay, for literature review, I just focus to mean of escape. This mean escape route. Mean of escape is an escape route that lead to a place of safety such as open air, outside building, or in large building where it's not possible. It should be possible to reach a place of reasonable safety such as protected staircase where people can travel in relative safety to a final exit. Okay, evacuation time is actually have three stage. First one is pre-movement time. This time is for detection, decision, alarm, and reaction. And then second one is pre-evacuation activity. Include time elapsed while occupants are preparing to leave of seek of refuge, and the third one is travel or movement time. Okay, this is principle of safety. The important thing is at least 2 way out remote from each other, and then have additional exit according to number of people and relative fire danger. Evacuation drill well planned, and then exit should be a reasonable travel distance and should be unobstructed, marked and well lighting. Okay, this is research methodology. The first one I will uh, do I do a preliminary survey and field visit. Okay, and then unstructured interview conduct in order to get the case study background and the layout plan, and then generate information such as floor plan, floor area, number of exit, number of staircase, and year of construction also obtained. Then after I get both layout plan, the layout plan draw in AutoCAD first before it can export to the computer model for simulation. So the CAD model will generate as DXF file and export into the SIMULEX software. And then in the SIMULEX software, the exit point were defined and located. This is actually I follow 100% in original hard copy layout plan that I have obtained. Okay, after that, because I focus on people who visit in shopping center, so the shopper are selected as people characteristic. So the people characteristic in this software was separate to 35% male, 40% female, 50% children, and 10% elderly. Okay, and then the density of occupant for every floor level I think is 2,000% and distribute randomly in each floor plan. Okay, after all information has been put and model complete, so uh, calculate the distance map. Distance map indicate the exit route for every occupant in that building. The simulation begin after this program finish calculating the distance map. So the simulation time depends on occupant load, floor area, obstruction, and number of exit provided. Okay, so the result of the number of occupants that evacuate the floor area generate every 5-second interval. So the total evacuation time for every floor level can be determined after the simulation end. So the result obtained for every floor level for both buildings were compared and analyzed. Okay, this is the process of SIMULEX. Import layout plan from AutoCAD, generate in DXF format, and then define and position exit point, calculate distance map, and then define and place occupant load and people characteristic. Simulation begin and result obtained. Okay, so the finding for shopping center A, this shopping center have 5 levels: lower ground, ground floor, floor 1, 2, and 3. Okay, so we can find the number of exits: lower ground 5, ground floor 5, floor 1 and floor 2, 4, and floor 3 is 3. So this is the result for first 5 seconds, means the number of person can evacuate in 5 seconds. Okay, within 3 minutes, 1475. Okay. TET means total evacuation time. Means the whole people in the building can evacuate. For lower ground is 8 minutes. For ground floor, 6. floor 1 7, floor 2 7, floor 3 10. So the total evacuation time for the whole building from level 1 until from lower ground to floor 3 is 39 minutes 38 seconds. Okay, for shopping center B, also 5 level, but the name of level is different compared to shopping center A. So shopping center B, floor 1, floor 2, 3, 4, and 5. Okay, this is the number of exit. Okay, floor 1 4, floor 2 3, 4 3 4, floor 4 4, and floor 5 3. And this have a different size with the door. Okay, for the first 5 seconds, you can see for floor 1 only 7%. As I mentioned, 2,000 people are distributed randomly for every floor level. So this is the first 5 seconds, number of person, and then this is total evacuation time. So we can find the total evacuation time for shopping center B is 25 minutes 30 seconds. Okay, then so the overall result analysis, the number of people that can reach the exit point in the first 5 seconds. Okay, we can see compare both shopping mall. Due to the different size of floor area, the result indicate that the number of persons can reach the exit point for shopping center A is higher compared to shopping center B. This is because the travel distance to reach the exit for shopping center A is shorter compared to shopping center B. Total evacuation time indicates that the number of exits provided gives significant influence to the time elapsed to escape. The result demonstrates that the size of floor area does not affect the escape time when the exit provided is sufficient. The number of exits provided is exerting a significant influence to the escape time for occupants. So the overall, okay, this one, the number of person that can reach the exit within 3 minutes. It found that number of occupants reach the exit point for shopping center B is higher than shopping center A. Again, it indicates the number of exits provided give influence to the escape time even though for the large floor area. The percentage of occupants can reach the exit point within 3 minutes in shopping center B more than 80% compared to shopping center A. Okay, for your information, so shopping center A was built in 1979. Meanwhile, shopping center B was built in 1997 after enforcement of UBBL 1984. Shopping Center A was built according to information during its time and may not be sufficient for fire life safety requirement for a large modern shopping center. So as conclusion, as stated previously, the purpose of this study is to explore the usage of computer modeling by using SIMULEX software. Two case studies were selected in order to achieve the research objective. One of case study was built before UBBL 1984 implement, and other one was built after that. It is found that the number of exits provided have a significant influence the effectiveness of evacuation. It also showed that the exit width influenced the effectiveness of evacuation. It can be concluded that the performance-based approach can be implemented to evaluate the effectiveness of evacuation process. This is because the effectiveness of evacuation process is an element that will be questioned by local authorities and the public whether the sufficient exits are provided for occupants to escape during emergency. This is my reference. Thank you.